With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us solve this question. The question says that statement 1 CHCl3 is more acidic than CHF3. Statement 2 CCl3 negative is stabilized through P pi D pi back bonding. Option A, statement 1 is true, statement 2 is true, statement 2 is a correct explanation for statement 1. Option B, statement 1 is true, statement 2 is true, statement 2 is not a correct explanation for statement 1. Option C, statement 1 is true, statement 2 is false. Then option D, statement 1 is false, statement 2 is true. So in this question, two statements are given, statement 1 and 2, and we have to check whether these statements are true or false. So in statement 1, it is given CHCl3 is more acidic than CHF3. Now let us see. Now if we take a general acid HA, when it dissociates, it forms H positive ion and A negative, right? After losing H positive ion, it will form its conjugate base, right? So basically the acidity of the acid, or you can say acidic strength, it depends on the stability of conjugate base, right? So always remember that acidic strength is directly proportional to stability of its conjugate base. More is the stability of conjugate base, more will be the acidic strength. Now we have here CHCl3 and CHF3. So when we take CHCl3, when it will lose a proton, H positive, it forms CCl3 negative, right? So here CCl3 is the conjugate base. Now when CHF3 loses a proton, it forms CF3 negative, right? So here CF3 negative is the conjugate base. Now we have to check that which of these conjugate base is more stable. So we have C negative, Cl3, and we have C negative, F3, right? So here in both the conjugate base, carbon has one lone pair, right? Now what happens if you see that in comparison of chlorine and fluorine, we know that if we take electronegativity, the electronegativity of fluorine is more in comparison to chlorine, right? So it will attract electrons towards itself. Both will attract because both are electronegative, but fluorine will more attract towards itself because it is more electronegative. So according to that, CF3 will be should be more stable, but this is not the case. Here Cl3 negative will be more stable. Now this is because in carbon, these two electrons, it is present in 2p orbital, 2p orbital, and in chlorine there is vacant 3d orbital. Chlorine has vacant 3d orbital, right? So what carbon can do? Carbon can donate this lone pair from its 2p orbital to the 3d orbital of chlorine. So here resonance takes place. There is delocalization of electrons. So in this case, there is delocalization of 2p electrons of carbon in 3D orbital of chlorine, right? So all these three chlorine have vacant 3D orbitals. So carbon can donate this lone pair to the d orbitals of chlorine. So this type of bonding is known as p pi d pi bonding. P pi d pi bonding, right? Now if we look at CF3 negative, here carbon electrons are present in 2p, but fluorine does not have any vacant orbital, right? Fluorine does not have vacant d orbitals, right? So back bonding is not possible. Back bonding is not possible, right? So here in CCl3 negative back bonding is possible and there is delocalization of electrons, so it is more stable. It is more stable than CF3 negative. So now this conjugate base is more stable. It means CHCl3 is strong acid. It is strong acid in comparison to CHF3. So it means the statement 1 CHCl3 is more acidic than CHF3. This is true. Now in statement 2 it is given that CCl3 negative is stabilized by p pi d pi back bonding. This is also true and it explains the statement 1. So here correct option will be statement 1 is true, statement 2 is true. Statement 2 is a correct explanation for statement 1. So option A is the answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.